ended with talking about, we talked about maybe how we could use modes from each technology provider. We talked about continuing with API discussions, things like that. So, Marian, if you want to get started.
Yeah, so we will want to try to establish how the APIs look like. So let me share my screen. Yeah, so our goal is to define a common control plane APIs that will be used in Sonic to be able to establish a peering session between two DPUs, to exchange all of the state and so on, and get the feedback from the DPU about the session state. So I have been taking a few assumptions and topology constraints into defining this proposal. So I want to go over that. First, we want to assume that peers share the same virtual IP, meaning that there is no notion of two DPUs for the host side. In case of failover, there is no action to be taken on the by the controller on the host side. All the configuration there stays the same. Backup peer advertises a longer path for the VIP. So that's how one of them is picked. And also some ENIs are active on one of the peers and some are backup on the same peer, meaning that for roughly half of ENIs, there will be an active traffic flowing through that DPU, but the other ENIs will be synced to by the peer and vice versa. Yeah, so if you have any questions on those, if not, we can go to the definition of the objects that we will that we propose.
Hey, so Marian, I don't necessarily have a problem with this, but I kind of understood it differently. I thought that it was like some form of ECMP that was like dividing like flows to the to the two DPUs, and not like like entire ENIs are active on one and backup on the other. That was just how I understood it to be.
I thought that the locally learned flows should be forwarded using that device, and as we sync locally learned flow information to the peer who's participating in HA, those flows will not be forwarded by the peer device, and in the same manner the peer device will have its own locally learned flows which it will be forwarding. Yeah, it could be done both ways. It would be good to discuss that.
Do we have Michael on the call, by the way?
Yeah, as long as the device stores both sets of flows anyways, it could be participating in forwarding for everything.
True. Yeah. Okay, so there is just
one more question on that. So what is a VIP? What does it really represent, right? It's not really is there another IP address for the peer that it would use for the flows that it is active? Because the third sentence says that it's actually not active backup, it's active, right? Some flows are on a peer, other flows are on the other peer. So how does the VIP work?
Yeah, so this is actually something that I ran into while trying to define the APIs and how the flows should look like, because right now, my understanding, there is a virtual IP assigned to every DPU that is hosting a particular ENI. And in order for the host that has that VM to which ENI belongs to reach that DPU, it will encapsulate packet into in the VXLAN header with the destination IP being this virtual IP. So that is how the packet, the network will know how to deliver a packet to a DPU. Now, the problem with that is that since we're talking about having this active-active scenario where some of ENIs are active on one peer and other ENIs are active on the other peer, it contradicts a little bit with the topology, with the DPU having one VIP, because it means that all of the traffic, it's all or nothing. It's either all ENIs will be able to access one VIP that is advertised with a shorter path from one DPU, or the backup will receive no traffic. So this is something that I wanted to clarify actually with Michael. Unfortunately, I don't see him on this meeting. So there are constraints that prevent us from having just half of ENIs active on one peer due to the topology. Because as topology defines it, we will have only one DPU in a pair that can be active at a time, or we would need to change the definition of topology, because how it is defined right now, that the active one is defined by a shorter BGP path. It will lead us to having all traffic going to the active one, not like Michael described it being half on one and half on the other. So that's a problem. That's an open question that I would like to sort out with him, but yeah, probably.
I sent him a note to see if he could join quickly,
Mhm.
and if he cannot, Gerald will be here, in about 15 minutes. But we can hang on to that question for sure. And I do
Yeah.
have to drop and rejoin because I can't see your presentation. So, but I'm going to let the recording keep going. But hopefully look for him to see if he dials in.
Okay.
Okay.
So let's continue. So probably some further clarifications will be needed, but regardless, I will move on to the definition of the session. It is so, since a quick background, since we are doing this for Sonic, this will be converted into SAI APIs. So the proposal here is to introduce one new object type, which is HA peering session, which has a set of attributes. So the first one is we need to identify the location of our peer. And for doing that, we should provide an IP address of the peer. But here is, again, a similar question from the similar place. How do we identify a peer? Probably by the IP address, but it cannot be a shared virtual IP because it cannot be properly routed to a virtual IP. So we should use some other address. Maybe there is a maybe there is a unique allocated address on the DPU, which is another loopback IP, or maybe we can use address assigned on a port of the DPU. So this is something that will probably need for further clarification how we do that. And this is a mandatory attribute. So the question here is, what address do we pick, and what will be the requirement for a DPU configuration in order to be able to establish HA session? Because again, virtual IP will probably not do. Then,
Marian, this IP address, are you saying that that's the IP address used for syncing HA information between the two peers? Okay.
yes.
Okay.
Yeah.
That
So this
cannot
is
be VIP, right? Yeah, that cannot be VIP.
yeah, it cannot be VIP because
Yeah.
we need to now instead of so the purpose of VIP is to deliver traffic from the host regardless of where which DPU is active.
Right.
And yeah, or even if we imagine ECMP use case again, it will be load balanced or something else. But we need some unique address, so hence we need to have some requirement for DPU configuration, how that will look like. Then administrative state. So this is basically for the session. Setting it down will just effectively stop syncing the information to a peer, but it will preserve the configuration of that session, then putting it up when both sides have it up. It means that the state synchronization can start. It is also a mandatory attribute. Then we have two attributes, role and ENI list. So those two are derived from the requirement that, or from the assumption that we will have granularity of HA on the ENI level, and and the controller will tell the DPU which ENIs are active. So for that, we will provide a list of ENIs to be synced with this session. So for the active role, connections belonging to these ENIs are sent to the backup, and role is defined by this attribute. So those two are also mandatory. But again, pending confirmation, probably by Michael, if this is the planned way to operate our session, because first of all, it assumes that we have per ENI active and backup, and second, it imposes a requirement on the controller to define which one belongs to which. And they are mandatory. Then operational state. This is a read-only attribute. It is required in SAI. Actually, the next slide is a notification about the operational state. However, SAI requires to have an accompanying attribute, like which can be used for polling. So it will tell us when the two devices are in sync, since the session was brought up. So we have administrator and we have operational. Operational means that they are actually in sync, and that the failover is like planned failover is safe to be performed. Then we have a pair of optional attributes. So this depends on the implementation, but I decided to include them right away because there was a discussion about that. But again, they are optional depending on the implementation. Like if implementation supports batching, we can specify the batch size. Those are kind of like a performance tuning attributes. We can specify message batch size, meaning how many flows can be compressed in one update message. And then message batching timeout. This one is the, let's say, a side effect of the previous one. It's the greatest latency allowed for a newly learned connection to be sent to a peer if batch is not full. So under some circumstances where we have not exhausted our batch size for a specified amount of time, it will be sent in a shorter message. To have a, let's say, a fixed or deterministic latency. So yeah, so these are the attributes of the session. They are expected to be configured by the controller. Any questions?
I just have one comment. I just think that the thing that you say message batch size should just say the maximum messages, right? Like
Max. Yeah, it can be max.
Right. I mean, in the description, it's, I mean, it doesn't have to be in the name. Just.
Yeah, so all the descriptions, all of that, I will convert this by next week into SAI pull request and send it for the community to review. And this will be the actual API to be accepted. Yeah, so.
For the max number of messages, right? Are we going to mandate a certain MTU size, or, just for the sync IP address?
MTU size is defined by the underlay SAI attributes.
Right.
Or do you mean like, is there requirement from the network perspective?
Right, because it's all based on the MTU, how many messages we can pack based on the MTU. So yeah, just for the link between the peers for the sync, if needed, we can mandate some size,
Right.
I guess that it's different layer. Like from the protocol perspective, it sent a chunk in the size of the max. Whether the network can send it in one packet or two packets, it's up to the network. It's very hard to correlate between those two because you don't really control the interface in which this packet arrives or sends, and what is the path MTU on that interface, right?
I see. So you want to allocate a large packet and leave it to the fragmentation and
or rather, we didn't discuss the protocol, right? Whether it will be TCP or RDMA or other, like, in every protocol, like a TCP or reliable, you can then send chunk and the protocol will break it into MTU packets. Fragmentation is one option, but it's not the only.
I see. If there is a new protocol, etc., then yeah, that can break it into multiple chunks.
Exactly.
Okay, then
Yeah,
we can reference.
Marion, I just have one question. You said like the controller is, making this API call. Is it the controller that has like understanding of the capabilities of each device? Like for example, suppose a device can only support a single message per a single message per packet.
Capabilities and capability query is already part of SCI infrastructure, and the corresponding capabilities will be exposed to the controller.
Okay. So like HA capabilities would be part of that query, if and so that the controller would understand, that it's programming this API within the capabilities of the device. Right? Okay.
So yes, SCI provides an API to query capabilities for any attribute. We can, of course, enhance that if we will find some information still is needed, but the general way of implementing stuff like that with SCI is to usually query first and then align with the expectations.
Marian, one other question on the role here. Is it limited to just active, or active backup, or do you want to explore other options of, high availability capabilities you want to drive? For now, you think this is good enough?
So I think it can be expanded if there is a need, but as I understand it right now, on the granularity of ENI, it is active backup, meaning that one DPU will receive all the traffic for a particular ENI, and it will sync all the flows to the backup.
Just a minute, in your schema, nothing prevents that, right? In your schema, both can be active on the same ENI. Like we are looking on one perspective, one box, right? The other box may have active state as well.
Oh, that's also true, yeah.
Yeah, you can have a role based on, the HA grouping and things like that, right? I mean, there's like all kinds of permutations possible here. You're active for this group, backup for the other group. It can complicate your life in whatever way you want. But I mean, this is an organic way to, at least say this is the base minimum requirement to just have an active or active backup scenario. And then if you have N2M or 1-to-N or N-to-1, all these, options become, much more,
I think that
so I guess that the question is whether in the peer list we have, it's a peer or a peer list, like should we have always one or more than one?
Right, correct.
Backup.
Then you have to change the API, right? So you have to have all that capability of not just having a peer IP, a list of peers, and how many of them are there, and what is the federation here across them, and for which particular HA group. So some of these things can become quite esoteric and very carrier specific, right? So is that to be explored here, or do we want to know?
I think yes.
And so, probably just a point on the previous thing that we discussed, right? The VIP. If the VIP is per ENI, then then it would make sense of what you're saying, right? An HA group is exclusively to certain ENIs to be handled, having only one active. That way, that VIP can be used by the hosts to steer all the traffic towards that appliance DPU. Right? In that case, your administrative, the HA session need to have maybe another attribute to say, how do you define that? All this, the administrative state or even role per ENI, isn't it? Or list of ENIs.
Yeah, but that's how you combine those two. Like one ENI on one DPU can be either active or backup. And this is defined. So you can create more than one session. But
so is the session per ENI? My question is, look at the role object, right? So
yeah.
how would the controller set this to be active? Then active for what? Which set of ENIs?
Active for the list of ENIs. Like those two are the attributes of the same session. You provide ENIs that you want to have synced, and you tell if they are active or backup for this DPU.
So it is ENI indexed, right? So that need to be one of the object or a key. What is that key?
Oh,
we
like, hold on 1 second, I lost the slide. ENI is the, it's the object ID. So if you look at the SCI API for Dash, there is an ENI object defined. So expectation here, probably for next time when I will convert it to SCI, it will be clearer. But the idea is that you take object of ENI that you created beforehand when you were creating ENI, when you assigned like all of the mappings, like to from which MAC address this ENI is mapped, what are the QoS attributes, like what is the maximum CPS for that ENI, etc. And you know what vport or what VNI, what ENI you're talking about, and there is a handle inside for that object, for that entity, and you use that handle, that object ID in this list to specify that that ENI will have on this particular DPU will have a role active or backup.
Marian, do you assume that like for a given session that any of the ENIs in this list can have messages coalesced with each other, you know, as part of like a bigger coalesced message? Like, is that the reason why, like, is that sort of the reason why you should specify these as a list of ENIs and not call this API like one at a time on each individual ENI? Like, is there an implication to the coalescing?
There wasn't such an implication. It's just that this is probably a more natural way to define this kind of API, because usually, as I see it, there will be a set of ENIs that will have the same attributes, like saying I want to sync those ENIs to that other DPU.
So
usually,
okay, so I get what you're saying, but let me ask the question differently. If the controller were to, you know, combine a list of ENIs and make a single SCI API call, would that create a different behavior than if the controller decided to make multiple API calls with one ENI at a time, even though they all have the same attributes?
I don't think it should result in different behavior.
Okay. So as far as like message coalescing, and I guess we'll get to that at some point, like as long as the message is to the same IP address, then they can be coalesced?
Why not? Yeah.
Okay. Okay.
But is there really an advantage, John? I mean, it's an optimization, obviously, but you know, assuming that the ENIs are probably evenly distributed, you probably would. It makes it simpler to have session per ENI list, right? And only the ENIs within that session can be combined into one message.
I tend to agree to that, because otherwise you can find yourself in the tons of corner cases in which the timer are not the same, And now, are you combining them or not?
Exactly.
Like, what is the benefit of creating multiple session object with the same parameters again and again, and a single ENI in each?
I'm just, I don't know, that's what I'm asking, like, is like, I'm okay with saying if you do that, that will result in a different behavior. That will result in like no coalescing of those. And if you combine them all into one API call, then that list can be coalesced together. I mean, I'm okay either way. I'm just asking the question of like, what's the intent?
I think it's a theoretical possibility, but it just adds complexity and may not be really needed.
Yeah, I would say that all the ENIs within a session are coalesced, and DNI in a different session are not. And if you create two sessions with happen to be the same parameter, it's an optimization. We won't do that at the time. And maybe later on we'll decide to merge them into one.
Right. I think that makes sense.
So this is like PhD level optimization. Wait, yeah. I'm just teasing.
Yes, it is.
Got it.
So Marian, what about other parameters like whether the synchronization is best offered or mandatory? Like what happens if I'm cannot synchronize?
You mean like what is the type of synchronization that we choose?
No, so let's assume that in that case I'm an active, I have a peer IP address, and my peer is down. So first is the peer keep alive is part of that entity, or this is not the scope peer. Like keep alive is not part of
keep alive. Right.
And second, what happen if my peer is dead? For some reason, I cannot send my sync message. So do I continue forward traffic, or I reject every new SYN till I have a peer?
Right. Unfortunately, I don't have an answer to either of those, but
no, I believe it should be, again, keep alive. I don't know. It's a discussion. For the second one, I believe it's an option. It's like some user will prefer availability and versus like the ability, like it's asynchronous. So some connection won't be 100% sync in that case. But then it's a trade-off, right? Mm-hmm. And the other option is you're always sure that your two devices are in sync, but you're paying for that because if one of them is dead, you're not getting any new connections.
Okay, I agree. So the second one probably can be added another attribute. First one, we should define the requirement. I will add the second one when I will convert it to SCI.
Since this is a high availability, feature, if the peer is dead, then for those flows that have been synced, we should be forwarding it. That is the main idea of the HA, right? So, yeah, it should be forwarding. Of course,
referring to the new ones.
Yeah, new ones, right? New ones.
No, I was referring to new ones.
Okay, the new ones and the events closest to the failover, right? The events closest to the failover or such events that you're saying that the peer is dead and cannot communicate, that those cannot be fully guaranteed, and that we can define that, how much. Can someone please go on mute? Who is the sound coming from? Christina, if you can ask everyone to go on mute.
Someone who is drinking
if not
water.
Talking. Yeah.
Oh, sure. Sorry.
Somebody is brewing coffee.
Lisa? Okay. Anyway, events closest to those, closest to failover cannot be guaranteed. Otherwise, if we are in full sync, we have to continue to follow the API.
I don't think that that statement is necessarily true. I mean, I think that if you know, if let's say the link between the two peers is broken, you know, you could decide to not forward, for example, a SYN packet, and not even allow like a new connection to be established. Right. So like that, like, I don't think it's like true that you say like, oh, like, there's always this uncertainty around the failover where some connections are like in an unknown state. I mean, I think that you can guarantee that you know, connections won't be broken around the failover.
Again, it's a trade-off. It's clear that you can guarantee. It's up to the
Yes.
to the user to decide what he prefer. 100% guarantee, and then most likely all the synchronization is synchronized. They're always synchronized. And in case of a backup, your peer failure, you're not getting any SYN, versus something which is more loose, but most
Yes.
likely will give you more performance. It has some advantage, right?
I agree that there are trade-offs, and I also think that like that the vendors should have flexibility in which of those they support, and the buyers should have you know, their own sets of requirements as to what they require, right? But I agree with you. There are many trade-offs with respect to the HA algorithms.
I mean, it's just a function of scale and the deployment scenarios here we want to contend with, right? I guess to make these trade-offs. So, do we want the API to be, you know, flexible enough to do that, or do we want to kind of hardwire it in a way that we can organically improve on this as time goes?
I mean, I put out a proposal that tried to show like a way that it could be done without requiring the API, like these setup APIs to have knowledge of it, you know, where like the receiver of the sync messages is invariant. It just has a very fixed behavior, but the sender of the sync message has a lot of flexibility as to whether it wants to do things loosely or statelessly or statefully. So like, I think there's a way to allow like flexibility to the implementer without having to predefine what all those different flexibilities are, or even to have to define them at all. They could be vendor defined.
But I can implement both. I can implement the loose approach and the fully sync approach. I can implement both, believe me. So
that's great.
Now
that's great.
I want the user to tell me what to do, because each one of them, it's a trade-off, right? Loose as a lower latency in sending opening connection, because the SYN is immediately go to the destination without any round trip, whatever, and it has. So whatever, it's a trade-off, right?
But what if there's like, you know, 100 variations of loose? You know, do you want to expose all 100 variations of loose as something that that's like defined in Dash in the Psi API, or do you want those 100 variations to be something that's like configured outside of Psi?
What is it outside? I'm not familiar with any outside configuration in a Sonic box.
I mean, you know, I don't know. I mean, you could have some other way of, you know, I mean, I just don't understand. Like, let's say NVIDIA, you know, has like, you can do both. Maybe you can do, maybe there are 20 different trade-offs that you can make, and each one makes sense in a certain use case. Maybe another vendor has 50 different trade-offs they can make, and they make sense in different use cases. Do we have to define all of those and agree to all of those and what they are? Or is there some way that we can allow for that flexibility without having to have agreement? Like, I think that there's a way to make them all interoperate without having to agree on what they all are.
it's not related to the implementation, it's related to the requirements. It's related to the contract. I'm not talking about how I implement that. I'm talking about what the user wants me to do. And
Okay.
without instructing that, I really don't know. Again, there are trade-offs. Each one of the there is no good, like a bad or
I agree.
or good.
I agree.
There are
I agree.
two different approaches. Just that.
You're saying there's two different approaches. I think that there's 200 different approaches. I mean, I think that like there are all different forms of looseness, for example. It's not just like strict and loose. I mean, it's like you could be very loose, you could be less loose. I mean, there's like
what
many
is define less loose? Again, I understand what is loose, meaning best effort
okay,
synchronization.
I'll give
I
it,
expect you not to be in sync. And
okay,
you may have a query capability that the user vendor will tell you what will be what is the probability for you to be out of sync, whatever. So
yes. Yeah, I mean, I think like maybe it can be abstracted into something like like a value of like your loose value or whatever. Like it should be abstracted into something that like each vendor can decide what that means to them. I mean, like I'll give you an example. You know, there's potentially like 7 state updates for a connection. Maybe, you know, maybe more. Like there's periodic ones too, if the connection is long lived, right? Maybe in some cases you don't even sync the SYN, you only sync the SYN act. Like there's like many choices you can make about like which of those 7 events do you want to sync and which ones do you not want to sync, like in terms of being loose. And you know, that creates a lot of potentially a lot of variations. Also, like when you talk about strict, maybe only certain events you want to be strict on, but other events you want to be loose on. So that like it's not like I don't see it as that there's just like 2 modes and you can support both. I see it as that there's many trade-offs that can be made, and they could make sense in different use cases. And
John, the way I understand you, it seems like, you know, what you're suggesting is that certain capabilities that you want to introduce at, say, at the receiver side, right? And then at the receiver side, SAI API is flexible enough to really, you know, give these kind of requirements and these kind of, I should say, you know, attributes, setting of the attributes to say that, hey, what type of capabilities you are setting it up, and what would you like the receiver to do, right?
No,
so
not,
these things can be done.
No, so I think the receiver can have a very fixed behavior. I think it's the sender that has like a lot of flexibility, but I think that it's like each vendor like may come up with like better approaches or different trade-offs. And why can't we just like abstract it into some kind of like HA quality parameter or something, like in that quality value has a meaning for each vendor. From, you know, HA quality of 1 to an HA quality of 100. Because like I don't think that you can, I just don't feel that first of all that it's worth us defining like every possible trade-off, because there are so many. I think it would be better abstracted into some kind of something abstract, and then you know, give a lot of flexibility to each vendor to decide, you know, not just the implementation, but like which trade-offs they want to support and do.
Right. So the generality is kind of important, is where you're saying, so that you have the ability to accommodate different, you know, options as time goes.
Right.
And we can't support infinite.
Of course.
Yeah. John, I'd like to take your ideas and put them in the markdown format on the GitHub from where you wrote that out. I put it in the chat window, but for other people to see.
Okay.
For the ENI list here, we say that for active role, connections belonging to these ENIs are sent to backup, which means that the controller will never assign the same set of ENIs to the other peer of the HA session.
I think so. I think that's the assumption.
Mm.
That's my understanding. I think Marian needs to confirm.
Why not? It will assign those ENIs, but the session will be may be backup, but also it may be active. Like if we expect flows to be distributed across DPUs, if there will be use case for that, those two can be active, and then sending sync messages to one another. If there is a clear active backup for that ENI, one of the sessions will be configured as active to send, another one will be configured as backup to clearly tell the DPU to accept flows that belong to that ENI.
Right. So basically what you said is the controller will assign certain DPUs to be active for a given set of ENIs, and it would also assign other backups, correct? Okay, so from a forwarding perspective, it will be only one DPU who would receive the traffic from the hosts for that ENI.
Yeah, that's how I see it today. However, it is not restricted. The API does not restrict it to be like that. But that's the current use cases as I understand it.
If both peers have the ENI list, right, configured by the controller, then they will both be in active role possibly. Then we'll need to have a separate attribute that says sync connections or not, because the other side will already have it, you know. Sync the
No, hold on.
flows.
Even if you have two actives, only one will receive a flow anyways. Packets are not duplicated.
Receive the flow from the
host.
From the host. Again, there is all these other options of ECMP, right? So both could get.
Still,
No,
even
this in ECMP usually it's flow based, right? ECMP, you're not kind of a single flow will go to a single path usually.
Okay.
Yes.
Hi, Miriam. The nature of active or backup is based on the traffic, right? I mean, it's not so much of the controller will dictate that, isn't it? Because it depends on the load balancing across the DPU. I mean, if you receive the flow and you processing it, you are in the active role, then you are automatically synced to your peers.
No, I think it should be instructed by the controller to avoid unintended consequences. There should be an explicit instruction from controller telling please sync those ENIs, or please only please accept those ENIs.
So let's say if the controller set the role to backup and you receive a new flow, are you expecting that that flow should not be processed because he's in the backup role?
No, it should be processed. It should not be synced.
And then HA will break, right? Yeah.
But who will you sync it to? Like if you receive the flow, your peer is. It means your peer is down.
No, that's the reason why I'm asking if the role of active backup need to be explicitly set by the controller, because this is basically the load balancing from the server that will dictate what DPU will receive the new flow, right? And then if you know you always have an HA peer, if you're processing the new flow, then you would have to sync that flow to your peer. That's implicitly say you are active because you receive the new flow. Because otherwise, then what is the role of active standby? And how would the controller control the load balancing from the server to say which flow go where? To set the active backup role correctly.
So if you have load balancing, it is active-active. If you have ECMP, it is active-active. If you have one that is advertising a shorter BGP path, it will receive all the flows for that ENI because it is the only path taken by BGP. So if we consider active-active, it means that each peer will sync all the flows that it received to the other peer. If we have active backup, active means that it will again sync all the flows to the peer, but backup means that it will, if it will receive a flow, it is not syncing it to the other guy.
But it will
So just a
process
minute.
it.
I do agree that we need to define better why we need the backup state. Again, it's not actually you can have the two box to be active and still act like an active backup, right? If you are not doing ECMP, you are only doing shortest path, right? So only one will receive all the SYNs.
Yes.
And the other won't receive unless there is a failure. So now the question is why we need a state backup. What is different in the state backup than the state active? If your answer will be in backup, I'm not getting any new connections. Every new SYN is not forwarded because I'm a backup and I'm not supposed to get SYNs to my box to that ANI. I will understand what is backup and then we'll figure out whether it is needed, this behavior, in which you are rejecting any new SYN and you are receiving only old connection, like already established connection.
Well, that is true. That is true in general, but I still think there are very likely race conditions around the time the transition happened where a backup could receive a SYN.
Yeah, I mean, with the backup setting, it does have an implication when you handle the failover. Because if you go with the strict backup definition, that means you're not supposed to process anything new and sync. If that's the definition, then you have to wait for the controller to come down and change it, right? And your failover will have a bigger impact.
I totally agree. I agree that this is a clear approach in which a backup not supposed to process any new SYN and then you're waiting for the controller either to change your role or to bring up a new active and then you won't get any SYNs. But you're not forwarding any new SYNs at that point because it means that most likely you don't have a backup.
For the ECMP part, it's still unclear. If we are assuming both will be in active-active role as configured by the controller when the controller expects that these two peers will be equal cost, right? In that case, the flows will be distributed, and then and the role is still active. So we need a special configuration, or the decision is left to the device to sync the flows that it has received.
So, but in that case, are we suggesting that if we have active where we have ECMP or load balancing and so forth, that we have many to one HA, like many active basically are backed up by a single backup card?
They're just two devices in per flow, right? That one will be receiving it and it will be active and the peer will be the backup. So I didn't expect peer many to one, is just two so far is what I've seen. Marianne can correct.
In ECMP case, we have fully replicated flows and we have bandwidth divided by the number of DPUs. And then when one fails, all the bandwidth goes to the other one.
Right. So there are only two, right? So half of the flows will go to one, both are marked active, half the flows will go to the other one. Yeah.
I see. So in the active view, half of it is basically active, half of them are standby.
Right, and right. So then if we say that for active role, connections belonging to these ENIs sent to backup, that is actually a decision based on the new flows that we are receiving, the device is receiving. Even though both are marked as active, suppose, by the controller.
On some of the previous meetings, there was discussion of, like one direction of the flow going through the one DPU and the opposite direction of the flow going through another DPU. Like clearly in that case, like it's like, this, like it doesn't really have this kind of role of active and backup. They're both active for the same flow, just for different directions of the flow.
So in that case, the controller will set them to active, I guess. Like both of them will be active.
Okay.
Right? It does not prevent it. I believe that the role of backup can be actually, I just thought of another use case, not only what to do with the new scene. It's actually more, or can be related to optimization. Whether I'm supposed to get this traffic or not, whether to put it in my hot memory, like a cache or whatever, or I can put those flows more far from my hot memory and then only on demand put it, like move it closer. Because in steady state, I'm not supposed to get this traffic to my box.
Hey, John.
Yeah.
I have a note that says asymmetrical flow usage to be looked at by Michael, meaning different tunnel encapsulations in different directions. Is that what you meant?
Yeah, I mean, I
Okay.
think like Michael had mentioned, I think
Yeah.
it's been mentioned a couple times that like for a given flow that the directions might not land on the same DPU.
My
And
note-
so
My note says we need scenarios to plan for this. However, Michael does not believe we'll have scenarios except perhaps traffic from SLB forwarding appliances. And that's what I have right now. So it's possible. I guess it's possible, but maybe in the future.
I thought, okay. I mean, I thought like for NAT and like maybe, I don't know. I thought that there might be different scenarios where it will
Yeah.
happen.
Yeah,
Yes.
okay, I'll take that back with him. I'm just gonna have him join our meetings at some point when they get their proof of concept out the door. Okay.
Okay, so since we're running out of time, let me just say that I will put the updated presentation where the old one is. And for the next week, I will convert it to Sai and we can go over all the open questions from this week.
Thank you. Do you need the link to it, or do you need the link to the slides folder in the HA folder?
Probably,
that would be great. Yeah.
Okay, I'll put it in the chat window. As always, this has been fascinating. Thank you, everyone. I'm going to stop the recording and you all have a good day.
Okay. Bye.
Bye-bye.
Thank you.
Thank you.